So I will not duplicate this to English very much, but Maria, please, you have the audience. All right.
Thank you.
Thank you.
Thank you. So I prefer
For me?
not to use microphone. Just please yell at me if you're not hearing. Please let me know, because I need my both hands.
Take support.
Can you hear me? The line. Okay, good, perfect. So I'm Maria Lennox. I come from Finland, a Datacubist, and our product is Simplebim. And my role is develop data products. And today I'm gonna tell you more about our latest product, which is actually not totally new, but as it's built or as it's gonna to be published and built in Simplebim 12, that's something quite new. So we call that base model. And I'm going to show you what that is. First the theory and then with live demo. So our understanding or our point of view is that how to make IFC models structures and the values in the models work in the way that it's easy to find information, and when you actually find something you understand what it means. And then possibility to organize the model the way you need to be organized. So that's what we have been developing base model for. I'm pretty sure a lot of you know already what Simplebim as a software is. Is there, how many of you knows what Simplebim is? So almost everybody. So not going to any details, but our position in this building industry or processes is pretty much there. On the left here, you can't see, okay, the create part. There is the modelers, architects, engineers who make the 3D models, IFC model. And then on the right side here is all different kind of products that building industry, normally facility management, site, construction companies, cost estimators, logistics, everybody use for handling their processes, and probably would like to use IFC models in those. So Simplebim takes in IFC model, and with that you can actually edit the model to work better in the downstream. From our perspective, we kind of think that we make the IFC models work smoothly in other softwares in the way that we actually make other softwares better, including Vector IO. So, even though you have been using Simplebim, but the idea in this newest version is kind of how to process the models has changed. So the newest version is Simplebim 11, and one of the main tools that has been developed for that is, and has changed a lot how to work, is data flow. And the data flow is pretty simply put a kind of a structure where we have a library of different tools and steps that you can use for processing model, and then you select from there and add it on top of each other And step by step, you can run the process to model. Pretty simple one. And it can be very short one, like here, you very simple generic steps like exclude duplicate objects and add basic quantities and then add elevation information and then just export. Save like this, you can open a next model and just run it through. Or it can be 100 steps or even longer. It can be very complex, built in sections. And that can be also saved, reused in other models, versions, revisions. So in that way, you can actually save the work. Uh-oh.
Oh, sorry.
Nice. Just one touch.
Kaabeldub jah.
Almost. Yeah. Cool. No creep. So that's how it works. Very, very straightforward. So in every data flow step, every single one of those works, there is the same principle. Always the same principle. You need to have a target. A target means that you select one or multiple objects or maybe the whole model, and then you have action. Target, action. For the step, for the process, what you want to do. So that's easy. No. Because if you have actually worked with the IFC models from different projects, from different disciplines, from different modelers, figuring out or searching a kind of good rules to find the targets, to find the objects always the same way, it's not that easy, because if all the models came from the same person using the same software, the same export settings and same, always a good day, no mistakes, it would be easy. So the reality is that actually I have never ever seen a perfect model, ever. I have seen thousands of models. There's always something, and it's always a little bit differently modeled. And you kind of need to be a wizard to be able to always select the correct information, to understand it, to use it correctly. You really need to be a kind of expert and really, really good. And because there is quite a limited amount of wizards in this world, we developed this base model system. So it comes as a base model toolkit, data flow kit. And it includes 3 steps. The first thing, what you can do to the model is you standardize the data structure. This means that you actually copy the existing values always to the same property place, to the standard place. That means that you will always find information, and that goes to every single discipline. All models from all different kind of tools. So that's the first step. But even though you need to be very much in that project to understand what certain terms and codes and names actually mean in that specific project. So the next step is to standardize the values. First we take existing information, existing values, and put it in standard places. The next step is to enrich the building parts with always the standard names, always the materials with the standard names. That means that after that anybody can understand the content of model. So because you don't need to be aware of all different kind of codes. And on top of that, you enrich the model. You add information to the model from your perspective. That makes it possible to organize the model the way you want to use it. It can be locations, it can be adding different kind of classification or installation task or duration time or whatever. It can be maintenance things. So, but now in this middle standardized values step, what we actually do, we also standardize the targets. That makes also enrichment standardized. That means whenever, whatever kind of a model comes in, you standardize the properties, to create the rules, to standardize the values, then you can actually create standard enrichments. Let's say for certain objects, cost estimators would always like to do certain things. For certain objects, some logistic information should always be added systematically the same way. You can just plug in that enrichment. So that's when you scale up your work, that's how you also automate the process. Because you can scale and not redo over and over again everything. And once you have this kind of a process underneath, then you can automate in, for example, using cloud. And this is our newest product, which is going to also be included in this one. And that means that you create your data flows in desktop, and you send them to cloud and open those to the project people. That they just drop in IFC and it automatically goes to the cloud, runs your data flow and sends it back. That means that the wizards with the data flows, they can be just few or outside consultants. And the project people can just drop in and, get the benefits. So, like I said, what I'm going to show you now, it's, it's been up and running with Simplebim, but in an environment that has been available for about more than 10 years to a very limited amount of construction companies. And after that, even if it has been open for anybody during few years now, the environment is pretty complex to use. And but these are the references. So I have been personally using for hundreds of projects, thousands of IFC files, this system, but with the old environment. And here you can see the tower buildings. So this is a hospital, huge hospital. It's a, the same one. Then we're showing Signe in the middle of Helsinki, Tampere Arena. These are just, there has been hundreds of projects. So this works. But what is actually new is that now it's as a data flow steps. Now you can do it yourself and with desktop. Okay, so let's go to demo. I will show you how this looks like in Simplebim. Okay.
Was the disconnect?
Yeah. Sorry about that. It's a feature. It's vision. Okay, let's have fun with this model. This is architectural model, just one for a quick demo. So, ArchiCAD, that's the original software, and very typical ArchiCAD information properties here for walls. And what we do first, here we have base model, step 1, 2, and 3. So the first thing we take here, we standardize this model, the properties, and now it's done. What actually happens is, like I said, we don't take automatically any information out. We don't delete anything, we just add. But it's possible to, exclude values. But some people are very much afraid what will happen to the original information. So we don't take anything away, but here we added a Simplebim property set, and it automatically went through the original information and copied the original values to this standard data structure. So now I will isolate only to this Simplebim, so you can see what happens next. So this is how it looks like for different kind of objects, and it actually tries to find certain information if it's a window door or something like that, and you can add more properties, and you can fix if something default doesn't find correctly, so you can fix it. That's basic configuration, easy to do. But most of the values pretty much, it works pretty okay. So now, from this on, I have architect's information in this standard structure, and the difference between the original, of course, is that it's the structure is always the same for all object classes, and this goes through all disciplines too. So you can select anything, and it's always the name types and layers and materials. Everything is always in the same place, and just only one place. The next step is standardizing the values. So this is rule-based, and this means that it goes through the model and it adds again this kind of 0-2 information. So this means we added an information for building part, like a facade, and it's the names you can decide, but it means that it should be something that everybody understands. So you don't need to actually, here is the original, this is the name type, US1, but for me, for normal person, it's a facade, painted, and it's aerated concrete, the material. So this creates, actually it creates this kind of information, and this is all rule-based. So you can create the rules, and if the new model comes and it changes a little bit, you can just run it through. So now we have these kind of building parts here, and for materials, and now anybody can understand concrete, glass, gypsum board, steel, and wood. You don't need to go to the detailed codes. So this is just a kind of a next step for adding the standard layer, and still these would be also already a kind of a target, but this is probably not detailed enough. For that we have this third step, which we call data key, and this is the idea that where you actually add a combination of those three. And now you can see partition walls with aerated concrete material, gypsum board with 1+0 boards and 1+1 boards. Then we have the last information is it's a variable, it's a detail for specific use cases. For example, for material or logistic or installation calculation quantities, it's important to know if it's 2+2 gypsum boards. It's not just net area, something like that. So now you can have multiple different kind of combinations of those standard information. And it's already so much easier. Anybody of you could actually quickly find gypsum board ceilings and wood ceilings. That's it. Without understanding a word of Finnish terms for materials. Okay, so this is the base model part. This is something that you can do, save, run through your models and configure to the next ones. And but the idea for this is to scale up your enrichment for different use cases, to make it easy, automatic, plug in. Now let's add some enrichment kits or packages. I created for this demo for cost estimating, design management, schedule management, site management, and facility management, and then finally top management. So let's start with cost estimating. So everything I do next, all the steps, all the enrichment, all the targets are based on these base model standard information. So I can take this and plug it into some other project. So cost estimating, what they want. Normally what they want is they would like to have quantities. That is pretty important. So what we did, we added geometry-based quantities to every single object. Easy. But what we also did, there's always a situation where you need to calculate quantities for things that don't exist in the model. So now I have created a standard rule that in certain type of rooms or spaces, I would always like to have them floor material parquet. So that is generated, it's derived based on that. And now it's also created based on a rule that certain wet room types will also always get the wall types and waterproof underneath. So now it makes it visible. You have objects with name type wall waterproofing that you have decided what you have given the name. You can see related space. Okay, this is good. Toilet and bathroom, and then you can also see the related wall behind it. That's sometimes important for site, for example. So now we have added information and extra objects, and all of them as quantities. Then maybe design management is, okay, this is all good, but I would like to use, I'm a little bit old-fashioned, and I come from Finland. I would like to use this kind of Talo 80s classification system. I'm used to, calculating all quantities based on these totally different classification system. So I want to organize the model based on that. That can be some classification unique, whatever. It can be not classifications, but some other logistics. And then schedule management, maybe on a site, what normally people would like to have, they would like to calculate the quantities by location. And again, I have just created the steps with standard rules, which objects or building parts will always be split. But of course, the locations are project specific, that's for sure. Okay, schedule management, let's take that on it. And I added locations to this. Here we have it. Now I can standardize everything else, but not the shape and location of the prisms. But everything else, now it's split the floor, and now I can get all the quantities by, for example, section. But I also, at the same time, and let's see, let's take this view. I also decided that this kind of facade types will get split, or this kind of floors and this kind of walls, always. So it's your choice, you decide. But then I also wanted, because I'm on site, and let's take this color away here. I also wanted to organize the model based on installation tasks, because from my perspective, I want to, divide the model based on who is installing what and where, and that can be anything. But the tasks themselves can be standardized. So now the model looks a little bit different because it's from them, their needs. So let's move on. Let's go to site management, because site and on site it happens a lot of things that not just with architectural models. There are other, unfortunately, I'm architect, that's not unfortunate, but unfortunately, there are other disciplines, like MEP stuff, that ruins architecture. So, now I have added, I merged MEP model, and this one includes all MEP discipline from plumbing and piping and ventilation and electrical plans, everything in it. And what I wanted to do, and again, with standard targets for the steps, I wanted to create these kind of clashes. So what I wanted to automatically generate and find is I actually wanted to find when these, and now I selected only ventilation ducts against specific not supporting partition walls. Again, from data keys. In every single project, I want to find the inlets for the walls, not supporting walls, where needs to be drilled a hole for ducts. And it created these inlets. Every single one understands the name, the identity, and also it understands the wall type, or whatever you decide to inherit to that class object. And also it understands what MEP object goes through, the size, whatever. Because actually this MEP model, if I take away the colors, this one, and I just need to show you this because I'm not lying. I handled this, the whole MEP model with the same system. All information, original MEP information, standardized to the standard structure. And I can take whatever kind of object, it's the same structure, together with structural and architectural models. I also have these 02s, duct fittings or whatever, and elevation information and this quantity information. So I used this for finding those clashes or inlets because it's very hard to, every single one costs money, and it's very hard to track what is done and where. And when design change during the process, you just need to trust the subcontractor's word that this is how many. So this is a way that you can just automatically run and immediately see how many and where that kind of inlet should be. And then facility management. If I was somebody who responsible for that, for quantities and everything like this, it's good, but I would like to see where all the maintenance, all the kind of instruments and assets that needs to be maintained regularly, where they are located. So I run through the system that, or steps, again, with standard targets. I decided that I want to add understanding for windows and some ventilation and plumbing and electrical instruments and objects and the room information. So what I did, I first, now you can see, and also furnitures, but this is totally your choice. Now every single object here automatically understands 04 is, there is a system for this numbering. 04 is a location information. So here you can see the first one, connected space. Everything you see here is written into the IFC. This is just the groups made based on the values written into the object. So you can, if you export an IFC, every single object carries with it all of this. So now you can, it's easier to spot which objects are in which location.